Hello, in this video we're going to talk about proteins, specifically the 4 levels of structure in which they are folded to fit neatly into your cells. So let's not waste any of your time, let's get right to it. Now when we're talking about the folding of a protein, the 4 levels of protein structure, we're talking about a process that's kind of similar to DNA because those can be very, very long molecules. But they got to fit neatly into your cells. And not just one. I mean, if you think about your DNA, I mean, you've got 46 chromosomes. So inside of your cell, and not just inside of your cell, but inside the nucleus of your cell, you've got to somehow take 46 very long molecules and fold them up in such a way that they fit neatly inside of the nucleus of your cell. So for example, say you got a backpack. Okay, and you're going to go away for the weekend, and you've got to get 8 to 10 shirts, maybe, and some shorts, pair of jeans, some socks, underwear, whatever, all into this backpack. Now you could just shove them all in there and try to zip it up, and it's just going to be a big old fat marshmallow looking thing, and everything's going to get all crazy wrinkled. But if you take each of those things and fold them in such a way, position them in such a way in there, they'll all fit nice and neat. Proteins, DNA are the same way. For proteins, there are 4 levels of getting folded and arranged so they can fit neatly into the cells wherever they need to be. The first of the 4 levels is called the primary structure. Now the primary structure is simply the protein being built, taking the amino acids and connecting them in a polypeptide bond, forming a polypeptide. And again, you've got the 20, and you can make just a bunch of different proteins. But primary structure is all about the building, of the protein. Okay. Now that the protein is built, now the fun begins. Secondary structure is all about folding the protein in such a way to maximize space. Now there's a couple of ways that this is done. You got your A helix or your B pleated sheets. These are secondary structures of proteins, and most amino acids do one or the other. They don't do both, but you can think of it as the A helix. The DNA goes through the A helix process to where you can take the molecule and just twist it to where it spirals. It goes into a spiral, twisting it, and then you can take that like DNA, and once it's spiraled real tight, then you can press it down on itself, really condensing it down. The other way to think about those B-pleated sheets is if, say, I took a piece of paper and I would fold it and then fold it onto itself and just keep folding it, making kind of an accordion style folds to where I can take a sheet of paper and fold it down, alternating up and down to make an accordion fold, to where I can take a whole sheet of paper and put it into a 1-inch little square that's maybe a couple of millimeters high. So you can really condense those down, and that's the secondary structure. The A helix, the B pleated sheets are the 2 ways in which that is done. Okay. The third structure of folding a protein, called the tertiary structure, is in a way, now that you've got them folded down and condensed, now we're going to take that molecule and begin to coil it onto itself using bonds and connection points like that. The way to think about this is think about a garden hose. Okay, now there's lots of ways that you can store a garden hose. You can just grab it and throw it in the corner of the shed or whatever. But most people prefer to a little more organized than that. The classic case is just wrapping it around your arm and maybe putting it onto a nail. But you could also do that. And if you want to think tertiary structure, think about you got that garden hose and the circle, the loop, and you take the middle of that and squeeze it together and put a zip tie on it to really condense the amount of space it takes up. And then you can even take those two ends and fold those onto themselves and zip tie those together. And to really condense down the amount of space. Now, I certainly wouldn't recommend zip tying your garden hose. I mean, surely you use it, especially if you use it at all, like around here. We'd just be cutting zip ties all the time. But that's just some metaphorical examples of way to think about that. Is the looping and the coiling and then the linkage bonds to kind of hold it in place. But that is the tertiary structure. And the first three are done to just a single protein, a single peptide chain. The fourth structure brings in other proteins, as you will see. Now our fourth structure, quaternary, quart referring to fourth structure, it's all about taking multiple proteins that have gone through the first three stages of this folding process, and now you connect them together to form this wonderful structure. But you take individual proteins and join them together that have already gone through the first three steps. That's your quaternary structure. So that's a look at proteins, the four levels of structure, the four ways of folding and arranging the proteins so they can fit neatly into our cells. When we get together next time, we're going to be talking about nucleic acids. So we'll see you then.